So for our first speaker of the day, will be given by Professor Mati Goyal from Climate Change Research Institute, India, from India. Her main research interest is in the field of CO2 capture and utilization. And today she will give her talks on the topic of carbon capture, utilization, and implication. So over to Prof. Matigol for her talks. Please, Prof. Matigol.
Good morning. You got good afternoon. Am I audible?
Yes, you are audible, Prof.
Okay. I'm really happy to be associated and become a part of this exotic event being planned by the Lancaster University as a prelude to COP26, I suppose. The event is being organized with the aim to create awareness among the society about the climate change issues, solutions, and to initiate a debate. And today being the first of the 7 days program, which is being held at in UK, Lancaster's University from 20 to 27 October 21. So I will begin my presentation. I'll share my presentation shortly, but as you know that 26 United Nations Conference of Climate Change has been is being held in the month of November in Glasgow this year. This is the first time it is being held in Glasgow, and it will bring together the heads of states and climate experts, government and non-governmental organizations together to put a stamp on coordinated action plan to tackle climate change together. So this is a unique opportunity for how to handle the current situation, which is now becoming more and more, getting more and more emphasized in our daily life. And this annual event is being held after though it is an annual event, it is being held after 2 years because in 2020, the COP could not meet. So I suppose, and I thank the COP could not meet due to COVID-19 pandemic. So it has changed various ways, and I'm really thankful and regards to the organizers, Professor Arwa from Sunway University, notably, and his associates for conceiving this webinar on an important topic of carbon utilization, which is a little complex topic, but this is an important topic, and I feel to be honored to be a part of it. So thank you very much, Professor Arwa. And I start with sharing of this screen now. As Professor Arwa has said that he also will be the panelist, and he has also established an excellent center for carbon dioxide capture and utilization at the Sunway University. I had an opportunity to be there 2 years back, and we have a very important presentation from him on green solvents. And there is also a presentation from Professor Mazari on the importance on the machine learning tools for carbon capture. So I come from India and work with the Climate Change Research Institute. I'm an energy and climate change expert currently in communicating science with masses and to strengthen the interface between science, technology, society, and policy. And my research interests include carbon capture and utilization. So I greet all the institutions and researchers and eminent climate change experts in this webinar and others participating to this meeting. So in my talk, I will cover climate change, a role of CCU as a key issue before us. The CCU technologies, as they move out from the lab to field, will be my focus. And implications are discussed. Corporate sector initiative, I'll throw some light. And finally, I will describe the need for adoption of science-based targets by the corporate sector before I end. So this is the agenda which I have. And as you know, Intergovernmental Panel on Climate Change 6th working report has been just out on 9th of August. And it has said that the climate has started becoming, climate change has become a key issue. It's affecting every corner of the earth, and we have to take deliberate actions to remove carbon dioxide from the atmosphere to compensate for the residual emissions which remain from after the use of renewable energy or other process, so that we can generate net negative emissions. So this the IPCC's report has highlighted that you will need to take the intense, rapid, and sustained reductions in GHG needs to address the climate change. The earlier IPCC special report on carbon capture and storage has emphasized that estimated that economic potential of the carbon capture and storage could be between 10 to 55% of the total carbon mitigation effort until the year 2100. So that is the earlier study, and now it is the new report has also emphasized that IPCC is the supreme body in climate change, so we cannot ignore it. I was discussing about the IPCC report. It said that 10 to 15%, 55% of share could be there of CCUS by the year 2100. Climate change is a key threat for the today's society. We all agree, and it is caused by the greenhouse gas emissions, mainly carbon dioxide from the energy sector. Since the beginning of the industrial revolution, and the use of fossil fuel has been growing for meeting the increasing energy demand for the societies, and it has released emissions of CO2 into the atmosphere, and which has led to global warming. And over the past 800,000 years, the concentration of CO2 in the atmosphere has been, while it has been mostly fluctuating between 200 to 300 parts per million, since 1950s, the atmospheric concentration has grown very rapidly, and from 300 ppm to it has become 410 ppm in 2019. So this is the Morgan-Stanley diagram, which shows that how the dioxide emissions are increasing. And the BP statistical survey also identifies the 4 countries where most rapid changes are taken place in the recent years, in last 50 years, between China, India, US, and European Union. And these 4 countries have added almost 70% of the CO2 emissions in the 50 years. And this is showing the global change which has taken place in last 5 years from 2014 to 2018. So this kind of increase in atmosphere is taking place, and the cause for that is, of course, the carbon dioxide. Okay, we were discussing about the carbon dioxide emissions, the economic sectors which are responsible for carbon emissions. Of course, we all that the sectors like energy, the transportation, building sectors, and agriculture, they are contributing to the CO2 increased emissions, greenhouse gas emissions in the atmosphere. And this IPCC last report, 2014 report, suggested that carbon dioxide has the maximum share of about 75 to 77% in the global warming. This is the global warming picture of IPCC 2014. And to go back to the other study by the International Energy Agency, which was done in 2010 and which was discussing about the role of industrial technologies for CO2 emission reduction. And it suggested that maybe this CCU or CCUS could have as much as 31% share. The other options, of course, are the renewable energy use, which are shown here, and energy efficiency, as well as the CCUS. So CCUS share is quite high as per the projection and can be by 2030. So CCUS is one of the technologies to combat the carbon dioxide emissions. So before I come to the theme of today, let me also share with you that in 21st century, the new challenges are arising from the advancement of adverse impacts of the technologies which were discovered in the 20th century. And now the sustainability has become most important. So at the same time, fossil fuel resources have started depleting. Coal is no longer the king of energy. Crude is losing its sheen as black gold, and carbon dioxide is ruling the planet. So carbon dioxide is becoming the most important gas of this 21st century. It has been controlling the planet climate from the ages, of course, with a history of anthropogenic climate change, which is only 125 years. Natural changes have occurred in the climate from the millions of years, and CO2 concentration in the atmosphere impacted the temperature of the planet during various epochs. And the current epoch is due to man-made changes. So once we understand that, then I come to the theme, which is carbon capture, utilization, and implications. Carbon capture utilization, as you know, is capture of carbon dioxide and conversion of it into economically useful projects, commercial projects. While CCS treats carbon dioxide as a waste gas, CCU treats it as a resource. So it is an alternative approach to make CCU into value-added products. And carbon capture and utilization is a set of 3 technologies: capturing carbon dioxide, transportation, and carbon utilization. So each technology is unique in itself. And we talk of carbon capture, it is the separation of CO2 from other gases. Because it is in the gaseous form, we need to separate out CO2 and then purify it. So there are 3 critical situations for capturing excess carbon dioxide arising from power plant flue gas. This is a power plant flue gas, which can have concentration from 8 to 14%. And then there is industry of gases, industrial plants. It can have even more, like 12 to 20%. And finally, the air in the atmosphere, which has only 0.04%. So there are 3 capturing situations. Before I come to the technology, I just want to mention here that it is the technology which is used post-combustion for a power plant. For an industry, it can be used from the off gases, industrial off gases from various sources, either thermal boiler or a part of the industrial output. And from these 2 are the point sources. And these 2, it was estimated that there may be about 8,000 point sources which can be used for capturing of carbon dioxide. And a lot of research has been focused on the point sources. But in the recent years, direct air capture is also becoming, has been tested. And sitting in a room, putting a CO2 absorber at the ventilator, ClimateWorks has demonstrated a technology for producing CO2 and utilizing it into useful products. So earlier research, though, is still being continued on carbon capture. research has continued, and we continue to get new we continue to get new developments every year. The benefit from direct air capture is it can capture the pollution caused by the mobile sources in the air, and that's why. And now, as the technology has developed, it has spurred significant research interest recent years, and it is proving that maybe the direct capture may become more. It's quite expensive, but it may become. So I come to the carbon capture and utilization technologies. Carbon capture and separation technologies, as I said, it is the separation technology, the processes for which have been known for several years or even several decades, but they had to be tested on the field. So there are the processes like absorption using a chemical solvent simply, or using a physical mixing of flue gas, taking it out. There can be adsorption using solids which absorb CO2, and then regeneration methods, which are being researched, are pressure swing, temperature swing. They're turning out to be more efficient. Cryogenics is well known that cooling a gas. Now, flue gas, which has about 8% of CO2, has so many other gases. The flue gas is so much polluted. So by cooling, each gas can be separated because each gas has a different solidification temperature. Then membrane filters, different kind of membrane filters are getting evolved. So in a short presentation, I'll not go into the details of each of these, but I'm just summarizing that microbial biological systems like microalgae can also combine with CO2 and produce new proteins or lipids or biofuels. So it is both carbon capture and utilization in the same process. Then the pathways to extract value from captured CO2 can be grouped in two categories: non-conversion and conversion and non-conversion. Now, CO2 which has been captured, which has been once say taken out from the plant and then it has been purified. Now it can be directly used or it can be used after conversion. CO2 being an inert gas, it doesn't react directly with the chemicals, but we need to supply energy for reaction, either in the form of temperature or in the form of pressure, or maybe using the catalyst. So CO2 conversion processes involve more energy inputs for converting into materials, polymers, usable products. It can be converted into fuels. All these processes involve some catalytic methods or energy inputs. And non-conversion is simply injecting CO2 into the oil field, depleted oil field or depleted gas field, or enhance in a coal seam for coal bed methane recovery. Non-conversion can also be supercritical liquid, which can become a solvent, or it is directly used in the food or drink industry, but that uses are not economically viable for anthropogenic CO2, but these are other possibilities. Their carbon utilization technologies scenario is very vast, very wide. They're wide because there are very different processes used in each of them, and they all work towards the same goal of utilizing carbon dioxide. So, for example, the chemicals from fuels take the energy, we prefer to use renewable energy when we want to convert CO2, because otherwise the energy penalty becomes quite high. If renewable energy can be used for conversion, then it becomes more attractive. Then conversion of CO2 molecule into various fuels like formic acid, methane, ethane, etc. CO2 depicted in the depleted oil field, it goes, affects by pressure, changes the pressure, viscosity, and if the gas, if there is leftover oil, it comes out. CO2 mineralization reaction with the with the concrete, it can make the building material stronger. Microalgae conversions and mineralization is depicted here. Then another utilization pathway, BECS, that is growing the crops, which can be used as a source of energy. And this is bioenergy CCS, which is a negative CO2 emission technology. Forestation and reforestation, it increases the sinks of carbon dioxide, and thus it is absorbed. Biochar, again energy crops, and then using them in pyrolysis, the biochars adds to soil as fertilizer, and this is the coal bed methane in the coal seams. When CO2 is injected, it releases the molecule because it is more attracted by the CO2 molecule is releases the molecule. A large number of organizations who are working in the field of CO2 capture and utilization, as of now, a few of them are shown here, like international, their policy in institutions and mainly the engineering institutions. Maybe there are so many more, just has few only. And of course, there may be about thousands of academic institutions across the globe are working on carbon capture and utilization, as they are members of various network programs. So International Energy Agency, Global Carbon Capture Institute, Carbon Engineering, Climate Works, and there are government institutions like Mission Innovation Programs there, and the Carbon Sequestration Leadership Forum, with which I had an opportunity to be associated closely when I was working in the government of India. India represented as vice chair technical group. So this is only some pictures of the technical group meetings and policy group meetings which took place at different locations. And this is UK meeting, and then this was in Abu Dhabi. So various years, this was my learning phase of carbon sequestration. And so I just sharing with you. Okay. Before we close on this climate change, let us also see the future scenario analysis being made by the institutions, like for example, prominent institutions like Global Carbon Capture Institute projection for carbon capture for 2035 has said that from 2024 onwards, there will be a rapid increase of CO2 capture in various sectors, industry sectors, and it could be as much as 1,500 million tons per annum in 2035. This is an important parameter for us to decide what CCU future is. And the second one is the IA projection, which shows there is a shift of fossil fuel jobs by 2030, and in coal they will start declining, and there will be more jobs towards the renewable energy. So these kind of pictures decide on the future actions for us to be taken. And so with this, I will now talk on the second part about the field projects which have been taken in the field of, because each subject is quite vast, and large-scale demonstration projects are needed to validate the performance and cost of the technologies being developed by us. And Global status of CCUS project as on November 20 was 65 projects, out of which 26 were operational. And here one can see these projects have been, first project came up in 1995, the Sleipner project in Norway. And as of now, there are 26 projects in diverse sectors. This is also showing the sectors where these projects are in operation and as a timeline of these projects as they become operational. The size of the circle represents the size of the plant. And the red ones are in operation and blue ones are under construction. I believe there is a plant which has been started in Malaysia recently, and that project is in Petronas for enhanced gas recovery. So there is a development taking place, and I will showcase some of the 3 important projects only, of course, out of 26, and these on different sectors, like for example, this Abu Dhabi CCS project of Emeritus Steel Industry was the first landmark project in 2017, where the CO2 was captured from the steel industry, or it has a capacity of 0.8 million tons per year. And the feed was dehydrated and compressed and was then pumped into the for enhanced oil recovery at a distance of about 60 kilometers. So this project was timed with the idea of having a master city with a zero emission city. So all industrial emissions would, 90% of it could be captured and then can be utilized for enhanced oil recovery. And the Boundary Dam carbon capture project is the only project for coal. It is important because it is for coal-fired plant, and in Canada, one of the 824 megawatt Boundary Dam, the power plant has 1 unit of it converted the CCS equipment, CCU equipment, and so it has a capacity of 1 million ton per year. It is important because it started in 2014 and working in 2016. So for a power generation unit, this is an important project. And the Century plant. It is the world's biggest plant aimed for enhanced oil recovery, and it is from oil and gas production unit. It is a capacity, though it started with a smaller capacity, the capacity reached to 8.4 million tons per year, which is 10 times of the Abu Dhabi project. And it is the world's largest project for the sector. And it again captured and stored it for enhanced oil recovery in the Denver City Industry Hub, and it went up to 160 kilometers transportation of CO2 it involved. So these have shown that infrastructure, the CCS or CCU infrastructure is developing successfully, and it has helped us to evaluate the performance and the cost. And I will also touch upon some of the projects from India for the corporate sector, because all these project initiatives are from the corporate sector. And when we want to look at the technology, then it is as I mentioned, of course, we have not much data, but the Malaysia Kawasari plant is also joining hands with for Petronas, and it will be taking out the CO2 from the offshore regions, and it will be for enhanced oil gas recovery. It has been planned. So coming to the India, I would like to mention that India is an emerging economy having second largest population in the world. And so coal is the dominant energy fuel, no doubt, and we have high oil imports in India, but it is still one of the lowest CO2 emission country at present. per capita, lowest CO2 emission per capita, not total emissions. And also it is an vulnerable country because more than 500 people are getting adversely impacted by the climate change because they are as farmers or they are agro supply chain people, and such a and livelihood of big coastal cities. The Kerala rains which occurred yesterday and day before yesterday, they are getting affected severely. So this impact of climate change are happening, and economies therefore set high ambitious goal for the renewable energy sector, and has so far also accelerating the renewable energy development has reached about 96 gigawatts from the, which is more than double of the 5 years renewable energy capacity. And India is driving from the green growth and climate justice. So I am just showcasing here the project from chemical and fertilizer plant, which happened to be become operational in 2017, and the lowest CO2 capture cost and utilization of $30 per ton. So this was a unique achievement by Carbon Clean Solutions, a company set up by an Indian engineer. And not only this, the Reliance, many of the companies in India, corporate sector, are now setting their net zero goals, targets. And the Reliance plant is also based on the circulating fluidized bed process, and it is using catalysis for converting the CO2 capture into carbonates. So these are the two recent examples. And another important project is that our oil and natural gas company corporation has joined hands with the Indian Oil Corporation, and they are also using CO2 conversion from the refinery waste into enhanced oil recovery. And the latest is just very latest, about a month ago, Tata Steel carbon capture plant commissioned at Jamshedpur, which is a small plant of 5 ton per day, or say 2,000 ton per year, roughly, which has been again capturing CO2 from the blast furnace gas. And this project is simply using amine-based technology, also by the Carbon Clean Solutions, for low-cost CO2 capture. And it is proving that circular economy solutions are possible and will open new avenues also for the hydrogen economy. On its inauguration, the CMD of the Tata Steel has said that we will use this operational experience for putting the, and get the required data and establish the large carbon capture plants in future. So,
Prof. Matigoel,
yes.
we have another 10 minutes to finish your slide.
Only 10 minutes left?
Yeah.
Oh.
Yeah.
Okay. So I come to the key question now. And a key question is that under what circumstances CCU for production of fuels, chemicals, and value-added products developed can deliver climate benefits, and what are the total climate mitigation potential in the midterm and long term? Now, when we are talking of CCU technology, this is the most important question, but it does not have a direct response, let me say, because it is a direct and challenge. And different norms are being thought that it was suggested in COP25 that corporate sector should accelerate. We should accelerate CCU, then only it will be successful. Then it can be a climate benefit. So with that in view, but European Union has, for example, come up with a climate relevance plan and said that they will reduce 100 million ton at least per annum as their humble contribution. So that is one thing. And another is that global research networks are have come up for intensifying the role of research and research investment. For example, enabling CO2 reuse is one of the consortium of 12 European partners from industry and research for innovation and market development for CO2 reuse. Now, these type of research networks are many, And these are testing for practical devices. And for example, the CO2 CAM. CO2 CAM is also another research network with the University of Sheffield, UK. And they are having a huge network. UK is taking the leadership for carbon CO2 product development. So the point I would like to emphasize is that the universities are taking leadership role in such research networks. And though industry, they have a consortium of industries, researchers, and policymakers, but universities have a important role. And the Global Carbon Capture Institute has said that these networks are on the rise. Now they are increasing day by day. So there are many challenges, a set of serious challenges, but we can have the opportunities like countries are considering CCS acceleration technology projects, policy, corporate sector is implementing transition by taking action to commit to net zero across the industries, but the current status of corporate sector is far from satisfactory. So there, I will just briefly touch upon in last part about the science-based targets, and academia is investing in collaborative research. So the challenges can be three types: technical challenges, market challenges, and policies challenges. Mainly technical challenges are because of the high operational cost, high investment, energy panel, high energy for the conversion, the geography, additional cost for CO2 transportation if it is distant, and cost benefit analysis of the various options is not done. So many options for CO2 conversion, so it's a wide scenario, and which one is the best is not known. And similarly, the market challenges, climate benefits are not quantified. CCU has not been fully quantified. Utilities face financial risk in adopting CCU equipment, and there are hurdles for reuse of the products. The reuse of the CO2 product is, and there's which needs to be accepted by the markets, and there are no standards for such. So success of CO2 utilization actually depends upon the utilization of the CO2 product. Once product is accepted, then we can expect. So there is need to be standards for the CO2 utilization products, which are additional resources. And then there are policy strategies for research investment required if we need breakthrough technologies, incentive for use of low carbon technologies, deciding on the price of the carbon so that it is helpful for moving towards low emission targets, and use of solar energy or renewable energy in the conversion process may also need some policy support so that to make it acceptable. The prices, if they fall, renewable energy, then it will automatically replace the conventional energy in the utilization process. And the Paris Agreement on climate change implications are to both the protocol of Paris Agreement and Sustainable Development Goals. It can have the implications to both. According to the IA Outlook 21, investment in clean coal technology, including CCUS, must increase many folds. So this is, of course, suggested that investment must grow and the world must move towards net zero. So the Paris Agreement, which was done in 2015, already has stated that countries, we should have not limit the rise to 2 degrees centigrade over pre-industrial, and even try to make it 1.5 degree. So for various pathways have been given for CO2 reduction, CO2 peaking, emission peaking for various countries. So that is the main agenda for discussion. And then companies profile has suggested that 47% of senior executives support the aim of Paris Agreement, but 70% of the companies plan that they will show some progress only after 2030. So this is the situation. So I thought I will touch upon the science-based targets, which was the outcome of the Chile conference, which was held in COP 2019, COP25, where it was science-based targets were introduced to achieve the goals for the corporate sector. The corporate sector is expected to accelerate, and companies were asked to increase pressure on their suppliers for low, so that this will affect the world trade also once this comes into picture. Because if the countries are not able to reduce their emissions, the import-export will be affected. Then science-based targets are those targets that provide companies, I mean, what are those targets? They define pathways for reducing their emissions in line with the goals of Paris Agreement. And a science-based target initiative have been launched by a group of organizations, Carbon Disclosure Project, the World Resource Institute, Global UN Global Compact Program, to promote best practices for emission reduction and net zero targets according to the existing knowledge of climate science. So there, they are providing the guidance, they are giving the best practices, allowing, and if carbon capture use, which is if the companies adopt carbon capture use, which is cost effective, and the market exists for the CO2 capture, these two parameters, then it will have tremendous effect on reducing the GHG emissions. And this happily, about more than 1,200 companies are now signed this initiatives, SBTI, and they are taking action, leading the transition towards net zero. So this is relevant for us. With this, I'll just come to the final slide of closing remarks. Carbon capture and utilization is as a critical component in the profile of low carbon technology status is reviewed in my talk. Current operating capacity is reached is 40 million tons of CO2 capture per year in a large scale project. They are proof of concept, but still far from the impact on climate change. CCU provides a synergy in mitigation of option of CO2 emissions and climate change as a whole. There is no dispute on that. The amount of CO2 utilized depends on the demand for the products and their market acceptance. This is important. So for which the policies to give the standards for the products is required. With policies of adequate funding, market regulations, carbon pricing, etc., the CCU technology will be able to overcome the challenges. Some of it we highlighted here. Corporate sector has an important role in implementing the transition to climate action by committing to adopt science-based targets across all industries. So it is this is what I have tried to highlight. And corporate sector is the technology whether they have to change the process completely, manufacturing process, or we have to adopt the CCU, that is the actions which are required. So that can be SBTI initiative will be providing the guidance on that. And so the final conclusion is that technology is the source of problems, impacts we are facing today, and technology is the solution also. So we have to work for that, for carbon capture and utilization to be successful. Lastly, I'd like to just share the recent publication, our latest contribution in 2021, that is climate change and green chemistry of CO2 sequestration. So it talks about various options of chemical and biological routes and advances in carbon dioxide capture and green chemistry of its conversion using different catalytic processes like electrocatalysis, photocatalysis, electrophotocatalysis, etc. In the context of global climate change, focuses on different catalysts, heterogeneous, homogeneous, which is cost effective. I mean, that kind of research focuses on CO2 sequestration opportunities and challenges for India's energy security, and also provide an interdisciplinary outlook for academic exchange on climate research. Thank you for your kind attention. I'll request you for your feedback. So my email is given here. Thank you very much. And thank you, Professor Gaurav, for giving me this opportunity to share the perspective on climate, carbon capture and utilization technologies and their implications. Thank you.
Thank you, Professor Matigal, for an interesting talk.
Thank you for watching. Please subscribe YouTube channel to get latest updates.